Hey everyone, welcome to the second half of the class. We're going to cover chapters 7 and 8 for the remainder of the semester. So let's get right into 7.1, which is all about trigonometric identities. And we've seen some already. On this first page, you'll see some that are familiar, hopefully. But when you see that term identity, it's really just an equation, but it holds true for any value of the variable as long as it's defined for the functions. So in other words, if you see this equation here, that works for any value you put in for theta, whether it's an angle or a radian measure, as long as it's defined, okay? Meaning you don't get zero in a denominator. So you have your reciprocal identities. We've used those before. And then we have Pythagorean identities. They're called that because they are derived from the Pythagorean theorem. There's three main ones. We've used those a little bit to this point. We use them a lot in this chapter. And so sometimes it's good to look at some alternative forms of the Pythagorean identities, which just means you're rearranging the equation using equation operations. So we can maybe look at some of that right now. What are some alternative forms? Let's look at that first one, sine squared plus cosine squared equals 1. You can think about moving cosine squared over to the other side, like subtracting cosine squared on both sides. And so that would look like, then you'd have sine squared equals, and be 1 minus cosine squared. Right, so that pops up quite a bit. And these are going to be helpful just to recognize them. You'll see how we use them later when we do some examples. Or, alternatively, you could move the sine squared over. So we could leave cosine squared on the left side and move the sine squared over, right? So those come in handy. Same with the other ones, you can rearrange them however you want, right? Just moving things from one side to the other. Like we could see something like tangent squared equals secant squared theta. If I bring that 1 over, it would be a -1 on the other side, right? Or we could even see like that third one, we could see something like 1 equals, like move the cotangent over, cosecant squared minus cotangent squared. So you can see, these are just a few alternatives. There's many more when you're just starting to rearrange these identities, okay? We've got quotient identities. We've used those. So tangent is sine over cosine and cotangent is cosine over sine. And then these might be new at this point in the semester, the even odd identities, right? So when you have negative angles, what happens, right? So there's just some ways you can simplify an expression. For example, that first one, if you have sine of a negative angle, that's the same as negative the sine of the angle, right? Meaning, like, let's say you knew, or you're trying to calculate sine of negative 45 degrees. Turns out it's just the same as sine of 45 degrees, just the negative of that. Okay, and you can verify that with a calculator. So each one has its own little property. This is called an odd identity. The sign is odd because of that property. Cosine is even because the negative just goes away, right? So cosine of negative theta is just cosine theta. Or if you calculate it, negative cosine of negative 45 turns out to be exactly the same as cosine 45, right? Okay, so you'll see those pop up. So let's see where we use these identities. Here's one place, just kind of practicing with these even odd identities. Let's say we know that the cosine of theta is negative 0.435. Then what would cosine of negative theta be? Well, we know that cosine theta and cosine negative theta are exactly the same. So if cosine theta is negative 0.435, cosine negative theta is the same value. Those are always going to match. The second one, you know that the sine is that value. What would be the sine of negative theta? Well, we know the sine of negative theta is opposite the sine theta. So this one, I guess if I apply the identity, that's negative sine theta, or the opposite of sine theta. So that would be a positive 0.435. Okay. Tangent, same thing. Tangent is also odd, so that would be a positive 435 for that one. So finally, how about the last one? You know that cosine is 0.4, sine is 0.7. How about the tangent of negative theta? Well, tangent of negative theta would be sine over cosine, but it would be sine of negative theta over cosine negative theta, right? Which the negative for the sine just pops out front. The cosine, the negative just disappears. Okay, so negative 0.7 over 0.4. And then I would just have to calculate 0.7 divided by 0.4, which is 1.75. So this would be a negative 1.75. Okay, cool. How about 5 through 7? So on these types of problems, you're going to be given some information and you have to find something else. There are two ways really to do them. This section wants you to use identities, but sometimes the other way, which I'll show, is way easier. Sometimes it doesn't matter. But let's look at this first one. We know that the cotangent is negative 4 over 9. Theta's in quadrant 2, find sine theta. Okay, so what they're trying to get you to do is think of an identity that involves cotangent and sine, and then use that identity to solve the problem. The one that comes to mind for this one, if I'm looking back at my identities list, is actually this one right here, because I know that cosecant is 1 over sine. Okay, so I'm going to use that identity for this problem. So I'm going to write that identity down. 1 plus cotangent squared theta is equal to cosecant squared theta. Okay, and then I'm going to replace cosecant squared with 1 over sine. So 1 plus cotangent squared theta is 1 over sine squared theta. Now I have an equation that relates cotangent and sine. So if I know cotangent, I can find sine. My next step then is to replace cotangent theta with negative 4/9. So, and then from there, it's just going to become algebra. So now it's going to be 1 plus negative 4/9 squared equals 1 over sine squared. Okay. Now it's algebra from here on out. It's, think of sine theta as the variable that you're trying to solve for, and see if you can isolate sine theta for the final answer. Okay, so on my left side here, I have 1 plus negative 4/9 squared is going to be positive 16 over 81 equals 1 over sine squared. I guess I could have given myself more room to work here. Maybe I'll blow it up. Okay, let's see. I'd probably add the 1 and the 16 over 81. So 1 is 81 over 81. And so then 81 plus 16 is 97. So this is 97 over 81. A little fraction work. And then I can cross multiply maybe if I have two fractions equal to each other. So I have 97 sine squared equals 81 times 1. All right, it's getting a little sloppy. I'll clean this up and write it better in my completed notes. And then I would divide both sides by 97. So 81 over 97. And then finally, to get sine theta, I have to square root both sides. So that's going to be this plus or minus the square root of 81 over 97. Whew. Okay, fun, right? Now I can clean that up even, because the square root of 81 is 9. So this is 9 over the square root of 97. and then I would rationalize. So multiply square root of 97 over square root of 97. So I got 9 root 97 over 97. Okay, and then it did have that plus or minus, which I have to deal with. Now, going back to this, theta is in quadrant 2. What do you know about sine in quadrant 2? Well, quadrant 2 is above the x-axis. Sine is also always associated with the y variable. So that would be a positive. So sine is always positive in quadrant 2. So then I know this is just a positive final answer. Okay. Sorry, backed up there. Okay, so that's how you use an identity to solve those. Another option, and I'll do this with number 6, is to actually just draw it out and not worry too much about identities, but do it with the Pythagorean theorem. I think for number 6, it's going to be way easier to do it that way. It might have been easier even to do it this way with number 5, but I did want to show you one with the using the identity. But for number 6, I'm going to do it a different way to give you another option. I'm going to draw this one out. Okay, so let's blow it up a little bit. If tangent is negative root 5 over 6, and cosine is positive, so that means you're in quadrants 1 or 4. So it's not 1 because tangent is negative, so it's got to be quadrant 4. So I'm going to draw this down in quadrant 4. Draw a right triangle down there. And if tangent is opposite over adjacent, or y over x, right? So I would put negative root 5 over here and 6 there, right? Using that ratio of y over x. So this is kind of a method we did back in chapter 5, really. I think it was 5. Yeah, 5. And then now I can just find r by the Pythagorean theorem. R squared is 6 squared plus negative root 5 squared. Right. And then simplify that. That's 36 plus 5. That's 41. So r is the square root of 41. R is always positive. Don't worry about plus or minuses on that. Now find sine theta. And we know sine theta is the old school definition, y over r. Okay. And then that's gonna be y is negative root 5. R is square root of 41. All right. And then now just rationalize it. Sorry, I'm doing all sorts of crazy stuff here. Multiply root 41 over root 41. So we got negative square root. This is a little crazy. 205 over 41. Final answer. Okay. Pretty answer, huh? So they do start getting a little ugly here with the roots and all that. Okay, so that's the other method. Now, if you did, if you hit view an example when you're doing your homework, they'll probably show you the identity way, which is a little longer for that one when you have to find sine given tangent. But if you want to check that out, check out a view an example. But now I've given you 2 options here. You can use an identity or you can draw it. Okay. For this last one, if we know sine, want to find this other remaining trig functions, let's go back to the identity way, which is really what they want you to do here. So, well, we got to knock them all out. Once you know sine, cosine, cosecant comes pretty automatic, right? Because you just flip it over. Done, got one. Right? And then now I'd probably go to cosine, because I have an alternative form and identity right there. Let's use that. Cosine is 1 minus sine, but with squares in it. Right? So cosine squared is 1 minus sine squared. And sine is 4/7, so just plug in 4/7 for that entire thing. And then calculate this out. So we're going to have 1 minus 16 over 49, which is 49 over 49 minus 16 over 49. And then 49 minus 16 is 33. This is 33 over 49. That's cosine squared. I guess I should keep writing that. And then finally square root both sides. So cosine theta is plus or minus square root 33 over 49. And then where you choose plus or minus comes from which quadrant you're in. So what do you know about cosine in quadrant 2? That's negative, right? It's quadrant 2 is where the x coordinate is negative, which is associated with cosine. So this is going to be negative. Cosine theta is negative, and then we can take the square root of 49, which is just 7. Okay, 2 down. Now once you have cosine, flip it over to get secant. Secant is 7 over root 33, negative, right? Which is rationalize 7 root 33 over 33, negative. Let's go secant. Okay, what else do we need? Tangent. Tangent is sine over cosine, probably your best bet there. Which is, okay, sine is 4 over 7. Cosine is negative root 33 over 7. Invert and multiply 4/7 times 7 over root 33, negative. The 7s cancel. I'm going to go sneak off to the other page, and that's going to be 4 over root 33, still a negative on there. And then rationalizing to get the final answer, negative 4 root 33 over 33. Whew. Tangent. The last one is cotangent, which is just flipping over tangent. So I'll probably flip over this version right here. Now put the root 33 on top and the 4 on the bottom, negative. Okay. Whoa, what happened there? Okay. So that's that one. And that's using all identities. Again, if you prefer, you want to draw it out, that method, you could do it that way too, right? Just use the fact that the sine is y over r. Draw a triangle with y4, r7. Use Pythagorean theorem to get x, and then you can use all your y, r, x definitions from chapter 5 to knock them all out. Okay, I think that's enough for this video. I'm tired. So let's stop here, and then we'll revisit, or we'll continue with this packet on the next one. Okay, hope all's well. I'll talk to you later.